Hey guys, it's Terry again. So today on the Workbench, we have a Spartus alarm clock that does not work. Friend of mine, I believe this was given to him as a gift, and he has had this for over 30 years. And as you can see, it no longer works correctly. So we're going to see what we can do to get this thing fixed. Again, I'm streaming live. I've got no net, so this could go badly. And if it's embarrassing, I'm not going to post it. It's going to go away. So let's go ahead and get this started. Got it plugged in. Listening to it, I can hear a hum coming out of the bottom of it. Given the age of this thing, I'm going to go with probably bad caps, because it's always bad caps, typically in the power supply. Something he said is if you replace the battery on this thing, it will function, which is kind of interesting. So I'm wondering if there probably is something wrong with the power supply circuit. And that's why we've got this funky display right here. I was not able to set, trying to set time or anything like that. Display does not change. It does change the display whenever I go between alarm on and off, but my guess is it's because it's hardwired somehow. I don't know. We'll see how that goes. So let's go ahead and remove the battery here gently. And there is a battery in the battery compartment. Ooh! Expensive battery. Check this bad boy out. It's one of the Intercell lithiums. And this video is sponsored by Energizer Lithium. So these Energizer lithium batteries, I've been using these guys for years. Using them in high altitude balloons because they operate below 40 degrees below zero. And if you're wondering if it's Celsius or Fahrenheit, it doesn't matter. It's 40 degrees below whatever zero you'd like. And they continue to operate down there where alkalines and other stuff won't. And they last forever. So you can buy me a new clock. Well, this apparently this clock is dear to a friend of mine, and I want to see if we can fix it for him. He said, "Here you go, take it, see what we can do." So we're gonna try this out. Yeah, this is a good battery. I don't know. I'm guessing it's dead. Let me flip over here, plug it in, see what we can see if it has anything. All right, and let's flip to that side. Oh yeah, it's dead. It's dead. It's got like 1 volt. Dead, 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 dead. All right, so we're gonna call that done. All right, let me flip my power supply back on over here. All right, so we've got 9 volts. And if I electrocute myself, laugh. It won't be the first time. So I'm going to take this guy right here. As I recall, the small one on the device side, yep, is negative. So we'll connect that up here. And large one is positive. Connect that up there. Oh, looky there. It's alive. Good deal. So I'm guessing we've got something going on in the power supply here. So let's go ahead and disconnect from power. Taking that power away does turn the display off. So I'll turn my 9 volts off here. Go ahead and disconnect that, set this over to the side. Probably not going to need these guys later on. Oh, hey, Suzette. Yes, this is my Chewy shirt. All right, so let me get to disassembling this guy. So I find the correct screwdriver here. And I have no idea how this comes apart. Nope. Also nope. Just a big old bag of nope going on here. Looks like these guys should push out. Is there a seam there? Man, they knew how to make these things back then. Good Lord. It's hard to take apart an iPhone. Like I said, I'm working without a net, so this may be completely boring. Well, I know it's boring. I'm doing it. Oh, let's try this guy. Ah. Just does not want to come apart. I think he wanted me to do this to make fun of me because he couldn't get it apart. I'm talking about you, Michael. Oh, let's see. Maybe it lifts that way? Man, this thing is awkward. There we go. There we go. Put it back in. Maybe I got to get two screwdrivers out here to do this. There we go. Aha. As I'll look up to see if I unplugged it. So this thing comes flying apart on me. I've got one of the seams undone. There we go. All right. What do we have in here? Wow, not much. Not much at all. So we have a tiny little transformer over in the corner and some old school PC boards and flat wire. All right. I do have one of those flat metal laptop tools. All right. Let's see here. Well, I can tell the supply is coming up here. So this little daughter board right here. Ooh. Oh. There we go. Oh yeah, man, this is all just wires. Oh Lord, look at that. Okay. And man, what do we have here? Got some kind of funky little It's a full wave bridge rectifier, it looks like, but it has a one-off diode. So comes in up here. Well, here's where it's going to get interesting. Let's take a look and see what the waveform looks like coming out of this guy. And yeah, the screen doesn't look too good there. I need to get something to shade that so you guys can see it. Oh, we got Stefan, Bruce. Hey guys. All right, so yeah, let's see what the voltage off our transformer is. I don't know if I should scope it out yet. Maybe I'll just do it old school first. Use the Fluke 77. And then we'll hit it with the scope, see what we got going on. First thing I'm looking at here is this large capacitor they've got. I'm guessing that thing is it's shot because it's definitely past its service life, without a doubt. Yep, screen's coming back up the way it was. So I'm guessing this is going to be the AC side of this guy. That transformer. Flip you back around. Okay, and between the center tap and one side, we have 4 volts, and center tap the other side, 5 volts across the whole thing, 9.5 volts. So that's reasonable, I guess, if that's what's supposed to be going in there. And so it looks like there's a decoupling cap here right in front of the IC that's on there. So let me take a look at that guy. Look at the voltage across there. I'm measuring like 1.5 volts DC. How many volts AC across that guy? Also about 1.5 volts AC across that guy. Alright, and let's look at our cap over here. I wonder if we just have a bad cap. Whenever you plug up the alright, got like 3.5 volts across him. DC. Oh shit, really? Pardon my French. Got like 4 volts across this bad boy. AC. Well, there's your problem right there. Bad cap. That should be a nice steady voltage that's across the capacitor. It's got more AC across it than it does DC. So that's probably our problem. So it has reasonably short leads there. I'm going to put my nerd glasses on. I don't care. I really don't. And this is a 330 microfarad 16 volt cap. Okay. Let's go shopping. So, I bought this thing right here off of Amazon. Pick a cap, any cap. It's like 15 bucks, man. I got my own Radio Shack store here. Alright, so let's unplug it. Yes, Bruce, unplug. You shouldn't tell me things like that, because then you take all the fun away from everybody else whenever it goes crazy. 330 microfarad, 25 volts. Wow, it's even the same form factor. Perfect. I am going to go ahead and just replace this guy, because I know the service length on this. I mean, it's well beyond its service lifetime. Let me show you that cap. So it's this little guy right here. And I can never get anything to focus on this thing. There we go. That little guy right there. Fire up the desoldering tool. Now, one thing you got to be very mindful of on this older I guess it's retail stuff. Man, it will fall apart on you when you start taking it apart. And I've been told by my wife that I am to not screw this up because it's for a friend of ours. So I can't break it. Hey, there he is. What's going on, Michael? So, let's see if we can get this thing negative. Looking at the display is on the left. Someone remind me of that later on whenever I go to put this back in. All right. Are we warm enough yet? Is it burning my face? There we go. All right, I believe I have that disconnected. No, one of them's out. There we go. All right, so we're going to go ahead and put your counterpart in there. Negative to the left when facing the display. Turn you off, and nope, not the rework iron, regular soldering iron. All right, here we go. We're heating up. 300 degrees, 320 degrees, 350. I said about 350. All right, 400. Okay, we're almost done here. And see if we can solder this thing. I really need my glasses. I cannot see anything. Getting old sucks. we go. Nope, that is no good. I cannot see what I'm doing. So let's try again. There we go, that is good. Okay, looks good. And let's cut off the excessive bleed here. I do not know if this is going to fix it. In all likelihood, it won't. Because I do not do this for a living, I do this for fun. Okay, so let's go ahead and fire it back up. Cross our fingers, hope for the best. And it works. Very gently put that back up and show you the display. There you go, Michael. We're good to go. So yay. And it was all because of this bad capacitor right here. These things only have an operational lifetime of about 20 years. And once you get outside of that, they tend to go bad. When they go bad, it makes all kinds of weird stuff happen. But that was it. Bad capacitor. So, guys, thanks for watching. Man, I can't believe there are like 9 of you guys out there watching this thing. That's cool. I appreciate it. I got the best friends in the world. So, take care, and we'll see you later. Bye.